Okay, let's climb the mountain of confusion. We've got a rectangle inscribed inside of a parabola, and the parabola is y equals 12 minus 3x squared. We want to find the dimensions that maximize the area. So you tell me, what does the 12 minus 3x squared look like? Y-intercept of 12. And if you factor out the 3, you're going to see a 4 minus x squared. So the x-intercepts are positive negative 2. Okay, so we have a nice graph sketched here. And a rectangle is going to be inscribed on the inside of it. I'm going to call that an xy coordinate. What's driving this problem? What phrase is driving this problem? Largest area, I want to maximize the area. That's what I want to do. What's my formula for area of that shape? Length times width. I'm going to call this base times height, and I'm going to refer to that because it says its base is on the x-axis. So I'm just going to try to use consistent language. Here's where you have to come up with the aha moment. What's the base? Has to be less than 4. Good idea, not quite. 2x. So what Darren is seeing here is that this coordinate is x0, and this coordinate is negative x0. And so you went x units in each direction for a total of 2x. Is everybody okay with that? So what about the height? Y. So now the area is equal to 2x times y. Well, shoot, now I still got 2 variables for crying out loud. You can see this one. We have y. What is y? Y is 12 minus 3x squared, folks. Did the same problem last year. But now we're going to do it using calculus. So this is my equation. Area in terms of x is equal to 24x minus 6x cubed. Y the derivative. That's what we do in calc. I like it. Almost an excellent answer. Just we need a little bit more. But when in doubt, take the derivative. Just derive it, baby. Excellent. So now you're bringing it to the graph. So you recognize this is a cubic that's upside down. So Maddie's saying, I know that that graph represents area. And I want to take the derivative because I know that the maximum occurs when the derivative is equal to 0. Excellent. So that's the mathematical reasoning behind it. So how many spots is the derivative equal to 0? There's 2 of them. I want the highest one because the lowest one would be where you minimize it. That would be having negative dimensions, and we don't have negative dimensions. So we're going to try this out. Take the derivative. What's the derivative? Sweet. So I got 18x squared is equal to 24. X squared is equal to 24 over 18, or 4/3. So x is square root of 4/3 is 1.15. Done, right? I mean, all of our mathematical career, if we come up with x equals, we're like, that's it. No, we're not done. What does it ask for? I want the dimensions. What's the base? Double the 1.15, thank you. 2.3. Mr. J. Aki. And the height, how do I find that? Yeah, plug it into the 12 minus the 3x squared. So I'm going to take 12 minus 3 times 1.15 squared. 8.03. It's approximate, but that's pretty good estimation there. Yeah, if we did the negative, then it would be right here, and that would give us a minimum. Better? Any questions on that example? Do you remember that example a little bit from last year? Okay, let's try one that's a little bit more challenging. We're going to do one more rectangle problem, and this one's inscribed inside of a semicircle. And the semicircle has a radius of 16. By the way, I had a couple visitors third hour. Very proud of them for coming in. They got a couple problems done. Nice job. Okay, so I got a rectangle inscribed here. And I've got this coordinate xy. What's driving the problem? So area is still the base times the height. I need to identify base and height. So just a little bit different. Still 2x. So you see you have x0, negative x0, so therefore your base is 2x. Yes, your height is y, so area is equal to 2xy. We don't have an equation, folks. D and E. Oh boy. Like, we're not even doing limits. I gotta shut that down right now. Sarah, you had a thought? Okay, so you want to use a 16. You are going to use a 16, but y equals pi r squared. That is the formula for the area of a circle, but Sean is thinking about the equation for a circle. Nobody could remember it second hour either. X squared plus y squared is r squared. If you didn't remember it, the Pythagorean theorem is just the distance form, or is the equation for a circle, right? I mean, if you make this is x and that's y, and this is r. What's r? 16. So you end up with x squared plus y squared is 256. So whether or not you remember the equation for a circle or the Pythagorean theorem, they are the same thing. Just instead of a, b, and c, it's x, y, and r. Can we solve for y now? Yeah, we got y squared is equal to 256 minus x squared. So y is equal to the square root of 256 minus x squared. Can I take the square root of 256 and x squared underneath that? If you did that, square root of 25 is 5, square root of 16 is 4, 5 minus 4 is 1. But what is 25 minus 16? 9. Square root of 9? 3. So you can't take square roots over addition and subtraction like that. So you cannot take the square root of each one. If they were multiplied, then you could, but you can't do that there. So I do have a nice formula. Area in terms of x is equal to my 2x times my y value, which we just said was 256 minus x squared. What do we want to do with that? Do you know what that looks like? It's pretty tough to think about what that looks like. It's not exactly like we've examined a parent function of that in any recent time. The only way you might remember is from last year. This is actually makes half of the infinity symbol. If we graph the negative portion, we get the other half of the infinity symbol. So, so that's what it looks like. But let's say we have no idea what it looks like. All we can really do is just try to take the derivative and set it equal to 0. How are you going to take the derivative here? Product rule. Derivative of 2x. That was easy. plus 2x times, now I got to find the derivative of that guy. Chain rule. You see how you guys identified chain rule and product rule? I mean, that shows that you've learned something very important from first semester. Something you had no idea how to do prior to this year. So I'm proud of you. Good job. You to the 1/2. Like he doesn't get it. He's his second hour. Say it again. Say it again. Say you to the 1/2. You to the 1/2. Those second hour people, they just don't catch on very quick to us. Oh, well. All right. So I got the derivative 1 over 2 roots of u. What is u? 256 minus x squared. And what's the derivative of 256 minus x squared? Negative 2x. So when I multiply these together, what's going to go away? The 2's, but I get the negative x, so I get a negative x over the root of 256 minus x squared. The other side is a denominator of 1, correct? So what I'm going to do is I'm going to set this equal to 0, and I'm going to find common denominators. What do I have to multiply top and bottom by if I find common denominators? Yeah, I multiply by the square root of 256 minus x squared. So if I do that over here, I get 2 times the quantity, then 256 minus x squared. What does the numerator come out to be here? Minus 2x squared all over root of 256 minus x squared. So I found my common denominators. I created one fraction. Are we concerned about the denominator? No. If you look, do you know what your zeros would be in the denominator? Positive, negative 16. Look at your chart here. As you can see, negative 16 would create a vertical line, and 16, the tangent line, would also be a vertical line. That's what the denominator is finding for you. It doesn't really have any relevance with the problem. It's kind of fun to talk about. So let's focus on the numerator and where that is equal to 0. So we have 0 is equal to 512 minus a total of 4x squared. Is that something we can solve? Yeah. So 4x squared equals 512. So x squared is 128. Is there a perfect square that divides evenly 128? 64. So we get 8 roots of 2. Or if you want to write in decimal form, 11.31. So let's answer the question. The question is, what should the dimensions of the rectangle be? Well, how are you going to now find the dimensions? Times it by 2 for the base. So I'll have 16 roots of 2 inches by whatever the height is. How are we going to figure out the height? The height is your y value. So you're going to plug it back into my formula. 256, square root of 256 minus x squared. So we'll do that. Square root of 256 minus 8 roots of 2 squared. And I get 11.31, which was my 8 roots of 2. Kelsey is correct. It is a square in each quadrant. So it's a square in this quadrant, a square in this quadrant, and so it's a rectangle as a whole with, the length double the width. What do you think about that? Well, yes. So a square is a rectangle, but a rectangle is not a square. Okay, last example. We might actually get done before lunch. You can ask questions in the rest of the hour. Kelsey has first. Find the equation for the line tangent to the curve that has the largest slope. Oh, no. What's that? Oh, yeah, I did. That's right. Okay. Wow. Okay. This one doesn't look anything like our other problems, does it? So, thank you, D. Wyland. No box. Let's make the box. Let's organize our work. So, Jonah, what did you draw in the very first box? Yeah, show everybody else. Why did he draw that? That's the curve. So let's start just wrapping our brain around this problem. We want the largest slope. So largest in terms of value, if you consider like a number line, say -10, +10, what has a larger value, the green dot or the blue dot? The green dot has a larger value, though in terms of slope, we would say blue is steeper, correct? We're not wondering what's steeper, we're wondering which one is larger. So the green dot is larger. Everybody agreed? So think about this here. Slope, positive or negative? Positive or negative? So would you agree that our largest slope could not be occurring on these ends? Has to be somewhere in between. Slope here is 0, right? So it's got to be somewhere between there. Would you agree that it would be right in this middle spot? What point do we call that? The inflection point. How do we find a point of inflection? Second derivative. That is where we change concavity. Concave up or concave down? Concave up, down. So at this inflection point where the second derivative is equal to 0, that's where we're going to have our largest slope in this situation. So it says to write an equation for the line. What two things do I need? You need your slope and you need your point on your line. You just told me I'm going to need a second derivative. Well, I have my original function. What is f prime of x? And then f double prime of x. Awesome. So I want to be able to use my second derivative. We're going to set it equal to 0. -12 minus 6x equals 0. So -6x is equal to 12. So x is -2. So if x is -2, what does that tell me about my problem I'm trying to solve? What did I find? Okay, I think you guys are all saying what I'm going to write down, but you found the x value of the point on the line, right? And then you're going to use the x value of the point on the line to find the y value. How do I find the y value? Plug it into second derivative, first derivative, or original? Original. Anybody plugged it in yet? You get -20? All right, so what's the last thing I need to find? Which one tells me slope? First derivative. Now, according to our drawing, what kind of value should we come up when we plug it in? Should come up with a positive, hopefully, assuming that this graph looks like what we have. But so as we plug it in, you know, you got you plug in -2, so we have 2 plus 24, 3 times 4, we got 12, so -12. So we got 26 minus 12, 14. 14 is our slope. So my equation for the line, y plus 20 equals 14 times x plus 2. Let's write it into slope-intercept form. Y equals 14x plus 8. Now, you know, kind of want to know if I got it right because got to check something. So I type this in bold. I type this in not bold. And I want to see a line tangent. I changed my window so that hopefully it matches, you know, what I'm seeing. And I'm kind of nervous because I don't want to make a mistake in front of you guys because I feel rather judged. Like you know, at that point, like you know, yeah, I'm feeling pretty good about myself. hey, that's your lesson. Here's your assignment, so you can start right when we get back. We got 1 minute here to write this down. Yesterday I gave you 7, 8, 10, 11, and 12, or 22. You can now do 22. It's very similar to what we've done in class. Number 10, there's still a little bit of a trick to it. Even number 11, there's a little bit of a trick. 44, 46, and 56, we did a problem like 46. You could do that today. But 44 and 56, we're going to finish up those type of problems on Monday. But for those of you who are finding this far too easy, I want to encourage you to try the optional challenge problems. If you'd like to replace any of the problems we do in class with one of the optional challenge problems, they're so fun. They're super cool. And they're not easy. Catherine's already done 3 of them. Check her for some help. She's ready to go. Go have a great lunch, folks.